Welcome everybody to our Build a Tic Tac Clone workshop. Looking forward to this one. It's a lot of fun. It gives us a chance to put together a front end, some middleware, and access Cassandra running in the cloud, our Astra DB product, and build something that's kind of cool. That's sort of a TikTok clone. So we'll go ahead and get started. My name is David Chung. I am in developer relations at DataStax. And by background, I'm a developer and architect. I'm also an author and trainer. And I'm a Java person. I'm Apache Cassandra certified and worked on developing those certifications. I'm also Java certified and have worked on developing the various Sun Java certifications way back in the day. And the real proof that I'm a Java person, among other things, my phone number is 431 Java. My license plate for one of my vehicles is Java. And I have 8 children whose names all begin with J. You know where this is going, right? When my wife was pregnant with our 8th child, a daughter, I suggested that she be called Java Rose Chung. Now, see, I was using my thinking cap. Rose is my wife's best friend's name growing up. Sadly, it was at that point that I discovered, after 7 kids, I'm not really in charge of names. But I have a background in Java development, embedded development, real-time development, and machine control, some sort of non-traditional Java environments, including enterprise systems in Java. I also, like many of you, come from a relational database background, worked in them for many years, but started moving into Cassandra, working in the banking industry, and have really enjoyed learning how Cassandra works, working with Cassandra, and I'm pretty excited about our content today. So I'm going to let my co-presenter introduce himself. Sarma is a great friend of the Cassandra community, so Sarma, go ahead, take it away.
Hey, David, thank you very much for the great introduction. Even before Cassandra, I worked on many RDBMSs, mainly Oracle. I still work on it. I fell in love with Cassandra about 7-8 years ago. You can reach me out on the LinkedIn generally, just follow me unless we really connect with any question or anything. I don't accept any new connections, just to let you know. Check out my work at GitHub. I have posted several open source projects like Prometheus Grafana dashboard for Cassandra. And I also developed some Python code which generates sales. So imagine you build your clusters. There is no data. There is no use of that cluster unless you want to pump some data. So this sales app will be your buddy to generate a lot of sales data, and you can throttle how much data you want to generate. Also, setting up an email server in your own lab is very difficult. So I have published how to do that using Linux servers. It's like a private email server. There is a lot of research behind it because it's just difficult to get your own mail server. I also have a YouTube channel, Oracle by Example. Even though it says Oracle by Example, I do have a lot of Cassandra stuff on it. I'm a Udemy instructor. Check out my courses and stay on until the end of this session. You might be surprised with one Udemy course coupon. I'm also an addict video gamer. Like I play on PlayStation. So on YouTube, my handle is I love PlayStation. Also, I'm wearing my Cassandra Forward t-shirt today. So welcome to the session, and I'm excited and honored to be here today.
All right, thank you. And we are glad to have a passionate expert like you as well, Sarma, joining us today. I will have to say I'll have to make sure my allergies don't act up. I've become a little bit allergic to relational databases, and you said Oracle a lot during your introduction. All right, as we get started, a couple of things, ways to interact with us. Of course, during the live stream on YouTube, feel free to put your questions into the YouTube comments, and Sarma and I are watching those, as well as some other colleagues from DataStax, so we'll try to answer your questions as they come up. You can also, anytime, not just during this session, you can go to datastax.io/discord. That's dtsx.io/discord, and that's our YouTube channel. And you can chat in that channel and ask questions even after the workshop. So if you end up having trouble getting the hands-on work to compile or build correctly, you can go to Discord later and we'll get to you and try to offer you the help that we can. During this session, just a couple of notes. This is a hands-on session. Now, we're going to go through the hands-on piece kind of fast. So don't worry if you can't do it all live as we demonstrate it and talk about it. Because you can always, the code is hosted in GitHub. We use Gitpod as an IDE. We use Astra. AstraDB is our database. And Netlify, which we'll talk about, to run our services. And all those things will be available after the session. So if you want to come back and review the video and go through the hands-on content later, that's awesome. You can do that. And you can use Discord if you run into issues and want to ask questions. So I want to make it easy for you to do the hands-on work, whether you do it now or do it on your own time. So what we're going to look at today, we're going to look at a front end using React, one of the most popular, maybe the most popular JavaScript framework. Last time I looked, it was for building front ends. Now, we're not really going to drill into how to build the front end because our focus here is going to be on using the database and putting the entire application together. So we'll give you a largely pre-built front end application, and we'll look at a back end in JavaScript. And building that, we're going to use Netlify as our framework. And again, our focus is not so much Netlify. We'll look at how it works, but we won't ask you to build it from scratch. We'll provide that for you. And then we'll look at Apache Cassandra. And we'll talk about how it's different from relational databases. We'll also be using Gitpod extensively, so you don't have to download or install anything to build the application, but you do need to have a GitHub account. And we'll look at AstraDB, and we'll talk about what Astra is and how we'll show you how to go about and create the account you need to do that. So that's where we're headed. We're going to start by talking about the architecture of the application, and then we'll talk about the database. We'll be using DataStax Astra, and you see in that picture number 2, we see this Stargate, and Sarma's going to be talking about what Stargate is. We're going to talk about a back end using Netlify functions, the front end using React, and then putting it all together in a Netlify deployment. And finally, we'll look at resources that are available, including the hint Sarma gave you about a Udemy class that you don't want to miss. So welcome to the workshop. Our mission is to build a Tik Tok clone and take it to production using a global content delivery network and one of, if I do say so myself, the most robust and scalable NoSQL databases on the planet. That is Apache Cassandra running in the cloud. So we're going to do this in about 2 hours. This reminds me of the Mission Impossible theme. Your mission, should you decide to accept it, good luck. Remember, if you aren't able to follow along and do all the hands-on in real time, you can go back to the video and do it on your own time and use the Discord in case you have any issues. This is an interesting application. Vercel is a short video app, kind of TikTok-like. It's India's fastest growing application, and it's powered by Vercel using Apache Cassandra. This application exists today, sort of TikTok-like, with 300 million users, 250 billion hits a day. And this slide's a little bit old. Versailles and Josh have grown even faster than this. So just a little bit about applications, and as we introduce the architecture with which we'll be working, you have, from a client point of view, we're talking about mobile applications, you have iOS applications, Android applications, and then you have desktop applications. There are a number of strengths and weaknesses across the different application types. For example, native mobile applications may have very high performance and extended features, but a weakness is they use a dedicated language and platform. For example, if you're building, and I used to work in the mobile space, coming from the Java world, I'm an Android programmer, but I've been in companies where we had an Android team and an iOS team. And you had twice the development teams building the same application, sometimes even to the same specification and weirdly the same look and feel. So while native applications have a high potential for high performance, their dedicated language and platform may require multiple teams, and you have to install them. A strength of a native application, besides performance and maybe extended features like access to sensors in a mobile device, is that you can build an application that looks native on the platform. So you build a platform for Android that looks like an Android application, or an application for iOS that looks like an iOS application, has all the iOS user conventions or all the Android user conventions, and it's easy to learn. It's very smooth for the user to transition from the other apps they're using to the app you're building. Also, on the threat side of this, on the web application side, of course, you have to consider security, versioning, all of those things. So we may choose to build an application a number of different ways, and there's no right way. It's a matter of looking at strengths and weaknesses, opportunities, threats, and more, and deciding which architecture makes sense for what you are trying to solve. So web applications run inside the browser. And the nice thing about a web application is it looks the same as you see here on my desktop, on my tablet, on my phone. It's rendered the same. It's the same code underneath for the most part, and gives us a very powerful way to build an application. So the application architecture to which we'll be building is a web application. It's going to run in browsers. Which browsers? Well, any browsers. That's the beauty of HTML5 and standardization. You can run in mobile browsers. You can run in desktop browsers. It is a progressive web application, and that's going to be our client built using the most popular JavaScript application framework, which is React today. The front end that's going to serve this is CSS, HTML, JavaScript, and those things combined into React. The back end of this application is going to expose an API, and the API is going to be exposed over REST. That API is going to be exposed via Netlify, and we'll talk about what Netlify is as we move ahead. And the back end for this 3-tier application is a database, and you can choose whatever database you want: Cassandra, Mongo, Postgres, Oracle, your choice. But for our application, and Sarman's going to talk about why you would choose it, we're going to choose Apache Cassandra, or the cloud-based version of Apache Cassandra from DataStax, which we call AstraDB. It's really Cassandra running in the cloud. And here's a look at the popularity of some of these front ends. You see Angular in red is lower popularity than I should say the React is the green. It's the most popular. I've never used Svelte. I've used a little bit of Vue, lots of Angular, and lots of React. And React is popular for a good reason. It's very component oriented and allows you to reuse your UI components in a very powerful and simple way. So for today, the front end is going to be React running in Node.js. So Node.js will serve as the web server, and that'll serve JavaScript, HTML, and CSS content to us packaged up in React. The back end, you have a number of choices for this back end. You could have Java, JavaScript, Python. We're actually going to use Netlify, which allows us to expose functions. Netlify is similar to AWS Lambda in that it's a serverless environment that lets us very easily deploy and expose functions from a cloud-based server. So with this, we're going to be using a framework called Jamstack. The idea of the Jamstack is it decouples the web layer from the data and business logic. And Jamstack isn't the only thing that, the only way that we've done this in web development, but it's a very current way of doing it using modern technology. So in Jamstack, you have JavaScript, you have APIs, and you have markup, and then you generate static pages. What's the benefit of that? Those static pages, which contain JavaScript, CSS3, and HTML5, can be deployed and served by a content delivery network. So you don't need a lot of server-side processing for what are essentially static pages. It's a pretty cool concept and pretty efficient. So the back end is going to use Jamstack using Netlify. And underneath it, we have Node.js and JavaScript. And while we won't be writing the Node.js code or the JavaScript code for Netlify, we will take a look at the Netlify functions that get deployed as a part of this app. All right, the next piece is data. And I'm going to turn it over to my friend Sarma to talk about the data.
Yeah, so David, data is most important, right? If you don't save your data in a format which is flexible and you need performance, obviously, you cannot wait for your data. I do have a little bit of lag on which slide you're showing right now. So I hope we are looking at the OLTP versus OLAP. Yeah, give me 1 second. Let me refresh this. I'm sorry, I don't see the. Okay, so generally data is the most important piece in any app in the background. You store your data, you retrieve, and then starting from user login, we use data everywhere. So when you talk about the online transaction processing, what you're looking for is a hot data or the live data, which is coming in as transactions. There are thousands of millions of users these days for any website. OLTP is very important because it requires high speed or throughput, if you call it, or you can also call it in terms of response time. When you run an API, like from your mobile app, through the Jamstack you're building, or we talked about just now, you want the response from database to be quick, and that way your app is very responsive. We have another kind of workload we always talk about is the online analytical processing or OLAP. And these are some things we run on a large data sets, and we run them on a cold data, meaning data is already existing. They're stored for a while. It could be one day old data, or it could be months old data. But we run analytics workloads on them, and the response generally is not fast, meaning OLAP response is slow. You run very complex query, you analyze a lot of data, whereas OLTP you need performance and it should be responsive. So your transactions are small, the queries are small, but they run. We expect them to run millions of queries in the given few seconds. So now that we introduced, or we already know these two topics of OLTP and OLAP, we do want our application to be OLTP side, where we want a quick response. So let's move on to the next slide. We introduce Apache Cassandra on this on this slide. So some of you already might be using Cassandra, some of you are new to it. Uh, Cassandra on the day one, it was built using the concepts of distributed computing. So this is a distributed database. It is big data ready, meaning the day it was created to solve the big data issue or the problem. So it's big data ready. Read write performance, it gives you high performance in read write, or you can even tune it to whether your application is a read intense or a write intense, or you can balance it. Cassandra is flexible in that terminology or in the terms of read write performance. It is scalability and availability, right? Because I mentioned Cassandra is a distributed database. You have multiple nodes running the services, and you can add more nodes. We'll talk about what is nodes in a second. When you add more nodes, think of them as servers. Your scalability goes up, and because you have multiple nodes serving the same data, your availability is always high. And any of these new gen databases, they offer high availability because you need your application to be always running. Um, let's say, for example, Amazon, right? You cannot have a downtime. Millions of users are shopping whatever they like, and every minute we lose the availability, we lose money. So that is already inbuilt in Cassandra. There is a lot of automation, self-healing. It's basically how the cluster checks its own health inside the cluster. We'll talk about the geographical distribution. This particular this particular slide basically shows you all the important points you need to know about Cassandra. In next few slides, we'll look at more detail on why Cassandra is a good choice for any internet-ready applications where you want to have high availability. So let's look at the next slide where we introduce Cassandra as a distributed database. Obviously, by this time you got a notion that Cassandra is a NoSQL database. We already, in the previous slide while introduction, I said this is a distributed database. If you look at the topology or architecture, whatever you call, Cassandra always runs on multiple nodes. Initially, you choose to run it on 4 nodes. You can grow slowly when you need more capacity, more load. You actually increase number of nodes in your cluster. One very important thing I would like to introduce here is Cassandra is a multi-data center database, meaning on the day one when Cassandra was created, out of the box, it supports multi-data center. Um, in the next few slides, we'll introduce how it runs in multi-data centers, including multi-cloud. But what you get out of this particular slide is each node can independently handle the requests, meaning in Cassandra, we don't have anything called master or a leader. So in other technologies, if you looked at the databases, they have a master or a leader And if at all something happens to the leader, there is a election process, and next whatever is the next node becomes a leader, right? Here, Cassandra is a peer-to-peer technology. It uses gossiping protocol to check the cluster health or the node health. And since it is a peer-to-peer technology, it's a leaderless. The downtime is approximately none. Like, it's always available. If a node goes down, imagine in this scenario where you have 7 nodes, one of the node goes down, you still have 6. And Cassandra basically keeps running until you have quorum of nodes running. Meaning in this scenario, you need 4 or even 3 nodes up, your cluster is still up. And again, if you have more load, you're going to add nodes to increase the high availability in this scenario. Now, there is a lot of discussion we did on this slide. Why Cassandra is so powerful is in the next slide, we have the biggest user community. So Cassandra is already 10 years old now, or you can call it still young in the database technology. But in 10 years, this community has become a very strong place. I would like David to add some word here. Like, our Cassandra community, that is one thing I fell in love with, is not just the technology. I love community. That's why I'm here today.
Right. Cassandra's an open source technology from Apache. And even though I'm from DataStax and we have a number of Cassandra committers on staff and are involved in it, in the project and devote a lot of energy to it, DataStax doesn't own Cassandra. Apple may be the biggest Cassandra user, but Apple doesn't own Cassandra. Neither does Netflix or any of these other companies. It is a community. It's a very vibrant community. Cassandra is on the verge of releasing version 5, which will be a significant set of new features into the Cassandra world. And this is all coming about because of the community. Said I work for DataStax, but Sarma is one of our friends from the community, and it's awesome to have folks like that involved in the, I was going to say life cycle, but in the community of Cassandra. It is a very powerful part of Cassandra. You're not locked into any vendor. Cassandra is an open source product supported by the community.
And just to remove this assumption, right? When open source, somebody thinks, oh, if there is a bug, it takes too long to fix it, right? Since 4.0 came out, this was last year. Actually, 4.0 went through months and months of testing even before 4.0 final came out. And 4.0 was production ready on the release date, meaning all the bugs were taken care of. The testing was already done by the huge amounts of community members. And there is a new testing work frame which put in place, like, whenever there is a new release, they start testing it even before the product becomes available as a download. So there is extensive testing done by the community members. I mean, people who are contributing to the project and people who are using it nonstop. For example, Cassandra 5, David mentioned. Cassandra 5 will be released later this year, probably by end of year. We don't know the date yet. But I started running the snapshot version of it, which is pre-alpha. I just built it on my own. I'm just running it, doing all kinds of testing. Right now, it is not extensive on my side, but I'm sure other community members are testing it very well. So community is what makes Cassandra the best. And that's one reason I fell in love with it.
Yeah.
So let's move on to the next slide where we can talk a little bit more technical stuff again. We just wanted to get the community thing out there.
That's very cool, Sarma. I do want to make one quick comment. I was explaining to my brother-in-law, who's a scientist by training, about open source software, because he'd heard about it but didn't understand why I was excited about open source. And when I explained to it that The source is open, the community develops it. Anyone can look at the code, like Sarma has just built the pre-alpha version. Anyone here listening can do that as well if you like. My brother-in-law said, it's like peer review in science. It's more scientific. Very cool idea.
Yeah, that is true. I mean, community is what makes the product great, and especially with a strong community, we are able to come up with this new ideas. And obviously, Cassandra 5, we are all excited about ACID transactions.
Yep.
There are leaders talking about it, so I'll let you listen to Patrick, if you want to understand that. So let's go on with the multi-data center in Cassandra. So when Cassandra was released initially, it was obviously released it was built for a specific purpose to solve the big data issue. Like, we have a lot of data, we need to distribute the data and access the data quickly. The response time I was talking about. Now, how do you do that when you have your database in a single location, right? Many of our databases, we know the traditional ones, you cannot move them across globe. So Cassandra, on the day one, it was created as a distributed database as well. They said, okay, this has to be geographically located. So it was out of the box on the day one, it was a multi-data center database, meaning you can have number of nodes in the local data center, and then you can have the number of nodes, say not the same amount of nodes, they can be any size. So imagine in Europe, you need more number of nodes to handle the European customers. Then you can have more number of nodes sitting in the European data center. And then you can have a data center in Africa to support any of the local region in Africa. So number of nodes become part of a data center, and then you can have multi-data center setup. It's a single database across the globe, and it is distributed geographically. So enough said, this is a database which is distributed across multi-data centers, and each data center can be in a different geographical location. And then in the next few slides, we'll introduce multi-cloud. So let's see what is the next slide. Talks about Apache Foundation. David, actually go back to the Apache Foundation slide for a second. Just want to, okay, it comes later. So, okay, so we are looking at the Apache Foundation slide here. So as you see, many of these open source projects, which are Hadoop, Pulsar, or Apache Spark, Cassandra is part of the Apache Foundation. Huge number of open source projects are under Apache organization, and Apache is like a consortium, right, which controls all the code quality, let's say, right? David, you want to add something about Apache? Then we can go back to the nice slide of cloud.
Yeah, and Apache Foundation has been around for a long time, really since the beginning of the web and network computing, starting with the famous Apache web server, not used so much today, but for us old folks in the industry, we've all used Apache web server. They've also been very involved in some of the web-based and internet-based standards, whether it's HTTP and others, very influential. And for Cassandra to be a part of Apache Software Foundation, and there are other organizations and individuals and companies doing open source. But Apache, as Sarma said, is a consortium. There are tremendous communities, for example, around the various projects on the screen, Cassandra, Hadoop, Spark, Pulsar, Kafka, others. So it's really a benefit to be a part of Apache's Foundation. There's a well-defined mechanism for accepting a new project like Cassandra, a dozen or so years ago, for making changes and releases, for approving what goes in and does not, done by the community under the Sarma used the word control. I hate to use that word in open source. Under the auspices, under the guidance, or with the gentle assistance of the Apache Foundation. A lot of goodness there.
Yes, David. The word control is loosely used, but it's not like the proprietary
Right.
software. So we talked about Cassandra being multi-data center aware from the beginning. When multi-cloud came into picture, obviously we need to put Cassandra in cloud because that's what people are using right now for cost cutting. If you're running your own servers on premises, you have to deal with the server maintenance, patching, upgrades, and all that stuff. So many of us have started moving towards cloud because we don't want to deal with the infrastructure, and then all the infrastructure maintenance can be delegated to the cloud providers. So Cassandra, since it supports the multi-data center, uh, even from the beginning of cloud days, like AWS or Google Cloud, Cassandra had this. When you go study how Cassandra networks with each other, like the gossiping protocol, so underneath there is a layer where it can communicate with the nodes within the specific cloud. So Cassandra supports multi-cloud um, architecture, or support for multi-cloud is inbuilt in the core architecture. So it's not a component uh, developed afterthought, but it was from the beginning. It supported multi-data center. So multi-cloud was just a easy to enable scenario. And when we introduce AstraDB, we'll talk about, okay, we don't even worry about where it is hosted. We don't have servers and all that. So we'll talk about that in few slides. So some of these points we talked about earlier. Cassandra is highly available because of the you have number of servers. Um, and since I talked about having that, we talked about the architecture where we had 7 nodes. You can have number of nodes down, and your still services are up and running. So it's Cassandra is highly available, and scalability. I talked about adding more nodes, or adding or removing nodes is easy. And I'll talk about AstraDB, where you don't even know how many nodes are there. It scales automatically depending on the load. Um, we talked about the global distribution, which is the multi-cloud, or you could have your on-prem data centers connected with each other, and you could have multiple data centers across the globe. And then very low latency for, like, you can tune your, for example, your application is a read intense application. I talked about that read versus write balance, and Cassandra out of the box supports all of those. So that would be the best choice. Why would you choose Cassandra? Because you want to develop a mobile application or an application which runs on multiple devices, and that should be highly available and responsive. So Cassandra is one of the best choices. Um, then taking all that and putting it into the slide for today's workshop. Um, so going to the next slide. What we have is all the components in the front end and the backend JavaScript, what David already explained. For database, we'll take Cassandra. Now, DataStax took Cassandra and put it on cloud, and the product name is called AstraDB. So DataStax AstraDB, I've been using it for like more than a year now. AstraDB is the easiest product I have ever seen. You go to the AstraDB portal, where David will actually, while doing, I'll explain, we'll walk through how to create a database. It's like filling a form with 3 fields in there, and then you select which cloud you're going to run this AstraDB on, and then you click on create database. That's all you need to do. AstraDB takes care of scaling it, number of nodes it needs. It will, according to your load of your application, it will elastically grow or reduce the number of nodes. And it's almost a pay as you go model for the database. And it is completely serverless for the clients. Right, David, that explains a little bit of Cassandra and AstraDB for the workshop today. So shall we just have one slide where it says all, like, this is um, the explanation about AstraDB. We already talked about many of these.
Yep.
It is auto scalable, basically serverless. You never see any EC2 servers or any of these cloud machines. Um, AstraDB already knows how is your load, accordingly scales up and down. So you don't pay unwanted fee. Let's say on AWS, you're running EC2, you leave it there. You actually need to sell your house to pay the bill. And with Astra, you don't have to, because AstraDB will continuously monitor your load, and accordingly, on a Thanksgiving night, you need more load, it will increase it accordingly, the capacity wise, and then scale it down when it is not needed. AstraDB by default supports all multi-cloud. It supports all the major cloud vendors, and it is distributed. We talked about Cassandra. It's the same thing AstraDB is. Actually, Astra is built on Cassandra technology, so it uses all the good things about Cassandra, but now makes it easier for all of us to use it on cloud. Um, it's a NoSQL database. Obviously, it is built on based on Cassandra. Now we talk about this document and key value API, which is a Stargate API. And in our workshop, we are going to use the Stargate API. Again, Stargate is an open source API. Um, Now this API actually allows the applications to connect to AstraDB or Cassandra, and it allows you to query the data in whatever format you want. You want row column format, or you want document format, or a key value pair format. So Stargate API is very strong API, whereas you don't have to worry about how the data is stored, but you just write your application and you send your queries in whatever format you want, and Stargate will provide the data in that format. So data exchange is taken care by the Stargate API. And AstraDB as well as Stargate are both open source. David, anything about Stargate API I might have missed?
A couple of things. And Sarma, AstraDB isn't actually open source, but it's built on and uses a lot of the features of open source Cassandra, but reimagined for a cloud native environment. For example, Cassandra, as powerful as open source Cassandra is, open source Cassandra is a monolith. And you can't, for example, in Cassandra, scale up writer nodes and not reader nodes. You can tune things, but those are all tied together because it's a monolithic architecture. Astra is built same basic functions, but in a microservices architecture. So you might choose to scale up the number of writers for a write heavy workload, scale down the number of query entities. I'll just call them that. I like to tell people that AstraDB is what Cassandra would be if it had been written last year instead of 12 years ago, when we wrote it in a cloud native environment, knowing what we know about microservices and all of those things. You'd end up with AstraDB. Many of the features of Cassandra, as we said, are ported directly into Astra, and some features of Astra are finding their way back into the open source Cassandra. DataStax is a big contributor to the open source Cassandra community. Stargate, as Sarma said, is awesome because what Stargate does, this name is probably already patented or trademarked. Stargate could have been called Rosetta Stone, because regardless of the API you choose to use to access your data, you might be using GraphQL, you might be using a RESTful API, you might be using a document API. You can do that through Stargate. It's still stored in Cassandra, and Cassandra's native query language is called CQL, or Cassandra Query Language, But if that's not the way you're used to accessing data, you don't have to access it that way. And Stargate gives you that ability. Very powerful, powerful idea. So thank you, Sarma. The next thing we're going to do is we're going to work on some hands-on work. As I said, if you're not able to do the hands-on in real time, in other words, as Sarma and I talk about it and demonstrate it, don't worry, you can follow the video later. Also, all of the instructions and all the things you need are in the GitHub repository. And I've had the Nightbot chat engine put the repository link into the YouTube chat. So I'm going to switch my screen up here and go to the repository. And this is the repository. And there, look, the second Sarma just disappeared. It's like magic. But we're keeping Sarma. We don't want to get rid of our friend Sarma. All right, just a little technical difficulties. Ignore the man behind the curtain. All right, so here's the GitHub repository. And as I said, the link is in the YouTube chat, but it's DataStax Devs Workshop, Social Media TikTok. If you look, there's a link to the slides. If you want to see the slides, there's a PDF version of the slides available. And all the code we're going to be looking at, all the configuration is here. This is the README file, and the README file is going to give the instructions. So as we go through this, we've talked about objectives. Frequently asked questions, can I run this on my computer? The answer to that is yes, but you know what? You don't need to install anything. You can run it in GitHub. And that's really the easiest way to do it. In GitHub, someone asked about Gitpod. Gitpod is the online version of VS Code. And it's not just an editor, but it provides a full development environment, a very configurable, powerful development environment that you can use in the cloud. So nothing to download, nothing to install. No really other prerequisites. You don't have to pay anything for the workshop. We don't have a certificate for this particular workshop. Materials, there's a link to that. The homework, we're going to be doing this hands-on. So let's jump right in to creating an Astra account. Now I'm going to go in and sign in. I already have, and there's some oddities because I'm coming in through the corporate network and I have private account, corporate account through single sign-on, a number of different ways that I get to Astra. But here's my Astra account, my personal Astra account. And Astra, when you sign up, you get to use Astra a certain amount of usage per month. I think it's $25 per month free. That's a lot of usage. It doesn't sound like much, but it's a lot. And the nice thing about it is you don't have to give your credit card number. I work for DataStax, and they don't have my credit card number. So there's no possibility of accidentally spending a lot. And as Sarma said, like if you use an EC2 instance, having to mortgage your house to pay your Astra bill. You simply sign up for the free tier and use it until you run out. And then next month you get the same amount of credits again and use it until you run out. So the instructions, we're going to create a database. We're in the free tier. The Astra user interface has changed just a little bit since these slides have been out. So take a close look as I go through this. It won't be quite the same, but we're going to create a database. Now, I already have a database created for this workshop. So I'm going to create one, but not use these actual values. So database, create database. I have to give it a name. I'll call it DaveDB. I have to enter a key space.
So one quick note, David, there is basically people might have worked with other databases. They know something called schema. In Cassandra, we have key spaces. So what we do is basically a collection of tables are in a key space. and you can have multiple key spaces in a database. So uh, while you are creating your database, what you're doing here is the form I talked about having 3 fields. So you just specify the database name. When you're creating a new database, you just want one user key space. That's what you're creating. For today, we are using this demo key space. And then you select a cloud provider. Basically, we can go with any of the popular cloud providers. In the free tier, what I noticed is we have the Google Cloud as the preferred vendor. So you just select the Google Cloud. But then when you're looking at the regions, that's what I was talking about, data centers, right? Now, each of this cloud region will become your data center. By default, we have one cloud region, but you can upgrade your account from free to a paid tier, and then you have access to all over the globe, right? Then I'll let you talk about the regions just to browse through, and then also the good thing is you can see the price even before you click on something.
Yeah, that's a lot of usage for less, 36 cents for a million reads, million writes. Certainly for playing around with the application and storage, 25 cents a gigabyte. Certainly for just playing around like we are today, exploring how it works, we're unlikely to end up hitting those limits. So our
Yeah,
database is creating right now. So Sarma, I'll let you talk a little bit while we wait for that.
yeah, just to mention about the $25 free credit, right? I've been running AstraDB million transactions a month. I have never paid anything yet. So if you're just practicing learning, this is a great platform to start with.
So we'll just give it a
So
minute
by
while it
by the way,
connects.
somebody might ask, how long does it take to create a database? From anywhere between 30 seconds to a minute. Uh, so imagine what it is doing in the background, right? It has this Kubernetes platform where it is launching the pods, meaning setting up your servers. Basically, you never see them. Um, it starts the services, and that creates a database, then create a key space under it, and then we'll soon talk about how to connect to the database using tokens. So those are all being taken care of in that 30 seconds to 1 minute time.
Yeah, so we'll let this run in the background and we'll return to the slides and let Sarma pick up here. Let me switch over. So first part of the hands-on is creating the database instance. We'll look at the token later on. We'll need that in order to access the database, but the first part's creating the database. So the next thing we're going to do is look at the document or look at the database, and it is document oriented. So I'll turn it over to Sarma.
Right. So actually, we talked about the slide here. We can go to the slide where we talk about a little bit more of Cassandra architecture, how it stores data, um, how Cassandra works with table. Yeah, so we created our Astra DB, which is happening in the background. So we can talk about the data.
Yeah, so I think
So
maybe you have some lag there, Sarma. I'm
yeah,
looking
there
at
is
the slide with that talks about the partition key and primary key.
right. The slide number 37, right?
Yes.
Okay, perfect. Yeah, sorry for that lag, a little bit of lag between the YouTube live and what we are looking at. But it's like 10-second lag. So okay, so we looked at this popular diagram of having 7 nodes in the cluster, right? So we talk about partition key and the primary key. There is a clustering column. So generally, when we want to distribute our database, it's not an easy task. Basically, distributed databases are complicated to build, but they want to make it easier to use, right? So there are certain rules we have to follow. Obviously, every database has their strengths, the positive side and negative side. Um, when it comes to Cassandra, the way we partition the data is most important, because if you see in this diagram, if you imagine there are 7 nodes, 7 servers, you want to distribute your data across the cluster and properly, meaning load balanced way, right? So that way each node has certain amount of data, and the way we do it, if you go to the internals, we use the murmur 3 algorithm to calculate a key or a value to basically where your primary key, the partition goes, right? Now, just to avoid any confusion, there is a partition key and there is a primary key. So in Cassandra, even though we declare it as a primary key, there are 2 portions to primary key. First portion is the partition key, which tells which particular node will host this data or own the data. And the second piece is called clustering column. And the clustering column comes into picture when you see, for example, if you look at this data diagram you have on the right side, the network is what your partition key is. In network, you can see that forest repeats couple of times, and forest has multiple sensors. So this is basically the temperature sensors you spread across different regions. You have something called forest, you have multiple sensors there. Each sensor will capture a temperature at a given point of time. What we don't see on this diagram is the timestamp, and just imagine there is a timestamp column. But what you see here is at a given time, from sensor F001, what is the temperature captured under forest, right? So the forest is the partition key, and most likely sensor will be our clustering column, and which is not displayed on the screen here. But what you need to understand is Cassandra distributes this data using the partition key. Combination of partition key plus clustering columns will make it a primary key. This is done because we want to distribute our data across all nodes equally so that all nodes have some data. And then we talk about replication in a different slide. This is just talking about how the data is distributed across nodes, right? So the next slide, you just take the same data set, and if you distribute it across all nodes, so in the next slide, we see how it gets distributed. David, did you move to the next slide?
Yep, we're on
Which
the next
is
slide.
38. Yeah. So I'll give it a second. On YouTube is a little bit laggy. Oh, you know what happened? My YouTube fell 10 seconds later, so that's okay. I caught up now. So now on this slide, you can see we took all the data which we were showing in a tabular format and we distributed across all nodes now. So not a single node contains too much data or less data. Now it's mostly equally distributed. There is 1 or 2 nodes which have only 1 row in it. But as the table grows, it is assured that all the data will be spread across all the nodes. Now, advantage of that is obviously this is a distributed database. You have all data across all nodes, meaning you can now write queries which can parallelly query from different nodes, right? So not a single node is overloaded with all the data, all the work it has to do to retrieve that data. And then we can do some techniques where we can keep the related data in one place. So that way, let's say, for example, you're looking at data from forest for a given day, you can keep all the data in one partition in one node. That way it can read from one node and give the data very quickly. So if we move to the next screen, we talk about how the document API works or
Yeah,
the
and Storm, I'm
schema.
gonna I'm gonna jump in and
Yeah,
just
sure.
share something here. One of the things that when I came to Cassandra from relational databases, one of the biggest things that I learned over time was that Cassandra is not just new syntax, it's a new way of looking at data altogether. And having worked in our services group, The number one issue when we work with customers in Cassandra where they struggle is in data modeling, because the data modeling mechanism, the way we do it, the way we should do it, is so different from relational databases. In relational databases, often if you have, say, in Oracle, sorry, I'm going to sneeze, I said Oracle, but if you have a relational database like Oracle and you have a good data model, new requirements can come in that require new queries, looking up data in a different way. And that model, if it's a really good model, is pretty stable. We don't necessarily have to change the model to support new queries. It's in there. And someone who's expert at SQL can write a query to retrieve the data because it's in there. In Cassandra, the data is modeled to support high performance under specific queries. So in this picture, you see all the forest data is on one physical node, all the sea data is on another. That's because it's most likely that we're going to look at forest data together in a query or sea data in a query. We don't want our queries to go across multiple nodes. If you wanted to do a query for forest and sea and home data, there are ways to do it in Cassandra, but most of them are anti-patterns. So the way we define our data model, the way the data is stored, is important. In fact, in Cassandra, the data is physically stored near each other, not just on the same node, but in the file system, it's stored contiguously. Why? Because contiguous data doesn't require seeking we used to use hard drives, but now with solid state drives, seeking the virtual SSD head. It's just a contiguous read, and that's super fast. And high performance is one of the key design goals behind Cassandra. So you may say, well, wait, you mean so I have to do my data model differently? That's one way to spin it, but the other way to spin it is you can fine-tune the data model for exactly the performance you're looking for to optimize queries, optimize the data model for one another, and that gives you tremendous performance in Cassandra. I'll step off my soapbox now, Sarva. Sorry about that.
No, that's really helpful. Most of the experienced people come from the database world, RDBMS world.
Right.
You don't need to sneeze. I did not say that. So basically what happens is we are all corrupted by a normalization. Okay. When we look at Cassandra, it is very important to look at data modeling. So understand how to store that data properly so that we can retrieve it quickly is what is the modeling part. And Cassandra is not a magic wand, so we cannot throw some data into database and expect it to work, right? It's not a general purpose database. But that said, if you do your modeling properly, and there are lots of DataStax workshops on the data modeling, I really
And I just had to
totally
throw up.
support that.
I just had to throw up a screen. That's my t-shirt design. I think that should be
That's good.
an official Cassandra t-shirt. Denormalization is the new normal.
Yes, definitely. What you said is correct. So basically, it's very important to model our data according to what we want to serve. Let's say, for example, if I'm a database operator like now, I need to serve to my application. I will have to model it properly. Cassandra, for a long time, has supported the JSON documents or data stored in format of JSON. And basically, in the screen, it just shows you just by adding that JSON as a keyword in the select statement, you can get your data from the videos table in the JSON format. Cassandra already supported this well, and Stargate API takes advantage of this and pushes the API to the newer limits. Like, say, for example, there is no limit because now you can do graph query language, or you can do document API. You can use key value API on top of Cassandra data, right?
Yep, very powerful.
let's look at more powerful people here. So I recently watched FastX. I wish this Jason had a little bit more screen time. Uh, I liked FastX, if you ask. So anyway, back to our topic, right? You see, in a couple of slides, we talked about why schemaless, or like basically how Cassandra supports JSON. Um, and this is all going back, and we'll tie it back to the Stargate API, right? So what you see here is a fun slide. Just puts everything in one slide with a nice celebrity. Okay, so now we're talking about API, I guess. David, Stargate.
Yeah, this is the Stargate slide. And as we said, Stargate's a data API gateway that sits on top of open source Cassandra, AstraDB, and DataStax's Cassandra Plus, if you will, DataStax Enterprise, which is Apache Cassandra plus a number of features that people commonly request or add on their own. DataStax has packaged those features into a product called DataStax Enterprise. But what it does, it allows you to access data in whatever mechanism you're used to. So if you're used to accessing data with a RESTful API or with Google's gRPC or GraphQL or JSON, you can do that. Ultimately, it's still stored in Cassandra in tables made up of rows and columns, though there may be a little bit of work to turn a JSON object or document into rows and columns. That's a tale for another day. But it allows you to view Cassandra through whatever API you wish. And there's actually a growing number of APIs. Stargate is a very active project and adding new features as we move along. Here's a look at the document model as we'd see it through Stargate. You have, within a key space, you have collections, and within collections, you have a document. So, where you have documents. So, for example, if I'm a car dealer, I may have a used car collection and a new car collection, and within each is a document describing each car. This is a white Chevy Equinox, 4-wheel drive with electrical driver and passenger seats, etc. That would be one document, and another would be for a green Ford Explorer. So the concept here is we have a key space, and as Sarma said, a key space is like a schema. It is a place where tables and custom types and so on are defined. So in a key space, if we look at this from a document-oriented point of view, a key space includes collections. It is a container for collections, and collections are containers for documents. And this is not strongly typed. The documents do not have to be exactly alike. There may be extra fields or missing fields in various documents. In fact, it's not even fair to call them extra or missing. They're just fields that may not be in every document in a given collection. If you've programmed in document-oriented environments using a lot of JSON, you know that's pretty normal. So see, it looks like we missed the slide. Yeah, we did do that slide. Okay, so next thing we're going to do is lab 2, looking at the document API. So I'm going to switch over back here and look at our lab instructions. And this is, again, in the README file in GitHub. So it says we're going to use the Swagger interface and connect to our database using the document API. So I'm going to go over here, and I'll go to my workshops database that I already created. And I'm going to say connect, and I'm going to scroll down. And I have choices, GraphQL, REST. I'm going to choose document. You can also choose drivers or other ways. Notice there are a number of different language drivers. This is not an exhaustive set. But for what we're doing, I'm going to choose APIs, document API, and then I'm going to launch the Swagger UI. What the Swagger UI does is gives us a user interface to show the RESTful operations exposed by a service. And this document API service has a number of get and post, delete operations, and you see their descriptions. List all collections, create a collection, empty collection, search in a collection, create a new document, delete a collection, and other namespace in documents the same as a key space in Cassandra. Delete a document, change the root element. There's a lot of things within a document and so on. So relatively rich API, lots of features, more than we're going to cover. We'll go through some basics. So we've launched the Swagger API or UI, and that's what you see here. And we want to look at the collections in the given namespace or key space. So I'm going to go back to Swagger UI, and this operation get is going to list the collections in the namespace. And to do this, I'm going to click try it out. So this will allow me to run a query live against the database. And I have to give the namespace ID. The namespace and key space are synonymous. And the key space we created was Tik Tok key space. So I execute. Here's the result. And this one actually has, because I did this before, it actually has two collections, the story collection and the Tik Tok posts collection. It really should have had no collections, but I played with this database before. That's fine. So that's how
David,
yeah.
Yeah, one small thing in the previous screen, if you go to that Swagger UI.
Yep.
Just want to talk about token for 1 minute.
Very good.
So whenever we connect to the database, we use username, password, or some kind of credentials, right? With AstraDB, the preferred way is the tokens, and the token contains certain elements in it, like username, password are pre-encrypted. So we don't even know what username, password looks like in a plain text. So token contains that format of already encrypted string. And it also contains all the information about where your cloud provider is or which cluster you're connecting to. All that stuff is an encrypted format. So if you give a token to somebody, they can connect. Obviously, you have to control that. But nobody can decode what is in that token. So just to know like where to get the token is on the AstraDB portal. And token is how we connect from our application to the AstraDB. So that's the database credentials, basically.
Right. And when you use the Swagger UI, because it's running in the Astra user interface, it knows the token already. So you didn't have to tell it. And by the way, the token we're using here and the databases we're using here will be deleted when we're done for security purposes. So I'm going to copy. You'll notice that the Swagger UI generates a curl command. I'm going to copy that curl command, open up a shell, paste it, and you'll see there it returned the same thing. It returned the collection. So the Astra UI is very powerful, and the Swagger UI that goes with it very powerful as well. Here's the response and headers, and you can see the other possible responses, error responses of various sorts, but the response was a 200, which is a success response. So we went through and looked at the various key space, the various collections. We listed the collections, tried it out, and did that. And now we're going to create a collection called story. And the way we're going to do that is we need to have a namespace in which to create it. And since this is a RESTful request, we use JSON. We're passing JSON in the body. REST isn't necessarily associated with JSON, but this REST API is. REST APIs can use other mechanisms. So we say try it out. And here's the collection I want to create. And the key space. So we copy the key space from my other screen. And we'll see if this works. The reason I say that is because this key space already exists. Because I created it later and forgot to delete all the stuff. So I'm going to run it. Yeah, it said create failed, collection story already exists. And I'm not surprised. In fact, I'm not bothered by that at all. I should delete first and then create. I'm not going to bother to do that live, but this shows you how that works, how I would go about creating a collection. I need the key space or namespace in which to create it. Key space using Cassandra term, namespace using JSON term. And then I need the name of the collection to create. And like I said, it failed because it already exists. So not surprised or bothered by that. We can create a first document, and similar, it's going to be a post operation following our RESTful conventions. And we're going to specify the namespace and the collection. So Tik Tok key space story. And I'm going to go and create a new document. Click try it out. And then I'm going to copy this document. But you know what? I'm going to make this slightly different because I probably already created this document. So we'll modify it a little bit. We'll give it a different name. I'll just say DC doc using my initials, DC. So we have, this is the URI that's being used following RESTful conventions. We give the namespace, collections, and the specific collection. Tik Tok key space, the collection is story. Let's make sure that, yeah, the name is story. And here's the document called DC doc. You know, so we're specifying the content type. We're passing JSON. I'm going to execute. There's the curl command. And you see that there is a 201, which means the item was successfully created, and you get back the ID of that document. So I can use that ID to search a collection. Here I can get all the documents in the collection, or I can search where username equals some value. So I'm going to do that. Search documents in a collection. Let's see, search. So here we go. And the namespace, oops, I've got to press try it out. Easy to forget that. And the where clause, only we're going to change that a little bit. I think we called it DC doc. And I'm going to execute. And we'll see if it found it. No, it didn't. Maybe I didn't call it DC doc. But if well, actually, I can probably search for the one that they want me to because I think that's already created. So where username equals Mufarouk32. I think that one's already in there. We'll execute, get, and there it is. I inserted that one yesterday or day before when I was playing with this, but you see how that works. And along with it, you see the raw curl command with the get request and all of the headers defined. So that's a look at the document API. We can also update a document using put, again, following our RESTful conventions. And you can delete a document using the document ID and the delete operation. And the author notes that, for example, the delete should return a code of 204. A create should return a code of 201 if it's correct. And a query should return a code of 200. If it fails, there are a number of failure codes that might begin with 400 or with 500, depending on what sort of failure it is. And again, that's standard internet conventions, web conventions, not specific to the document API or to Astra. The next thing we're going to do is create credentials for Astra. And I'm going to create credentials for my throwaway database, DaveDB. That's the one.
Yeah, David, one second.
Sure.
So go back to the Astra DB portal where you had that Swagger. So one takeaway, I mean, in the connect, just go back to the Astra DB portal.
Oh, back here?
And there is,
yeah.
On the portal, you have a connect, and then scroll down a little bit, you say document API. Scroll down a little bit more where you have the Swagger URL.
Mm-hmm.
So what I want everybody to take away from this is when they use the Astra DB portal, that Swagger API is by default written for them. They don't have to do any coding, right? So they just click on that URL that opens the Swagger UI. You have been talking about REST API,
yep.
JSON, and all that stuff. This is already pre-built. You don't have to write anything by hand. You just use that API or the UI, and then you start pumping your data. I mean, obviously you're not pumping large amounts of data with this,
right?
But it is very easy to, use the pre-integrated Swagger UI.
The other cool thing is if you're comfortable using Cassandra query language, there's a SQL console. And once this starts up, it's just like a SQL shell in any other environment. You can run CQL, Cassandra query language commands directly in the shell. And this shows me the various key spaces. There's the Dave key space.
And David, I want to mention something here. So you see on the SQL console window on the right side on the top, there is a pop-out button.
Yep.
So just click on that pop-out button, and then it brings you to a new tab with the full window, and you can increase the font and all that, right? And there is also a maximize button over there.
Yep.
So can you click on that maximize button? So Astra DB today, the portal has this option because I requested it.
Awesome.
So basically I worked with Dave and others to get that thing going. So yeah, I'm proud.
and you should be. There are a lot of, by the way, there are a lot of Dave's at DataStax. That would be Dave, my friend David Gallardi, who's in charge of the user or involved in the user interface and does a great job with it. So yeah. Well, that's cool. I didn't know you were the genesis of that. Awesome. All right. So under Connect, the next thing we're going to do is generate a token. And I've generated a token for my throwaway database. I'm going to delete the whole database after that. I'm going to delete both databases after this class. But I'm going to generate a token. And when you generate a token,
So quickly, there is a question on the YouTube chat. How come the majority of the workshops front end is React instead of Angular or Vue? Do you want to spend like a minute?
Sure. To be honest with you, if it were me, I would have used Angular, and that's because I have more background and have written more Angular code. However, as you saw on the graph earlier, and I see Kevin has asked the question, React is actually more popular. There are more by most everyone's measure, more people use React. if we were really drilling into the front end to show you how to write the front end code and the back end code, we would probably provide both. We do some in Angular and some in React. Like I said, I'm fluent in Angular. I'm conversant in React. I've written React code, but I've been a team lead and stuff in an Angular environment and done a lot of work in it. So it's just based on popularity and the fact that, React, even me as an Angular person has to admit, React is the more popular format. That's the only reason that we do that. Yeah, thank you for pointing that out. The other note on this, as far as tokens, so you get one chance to download a token. You can download it or save it. You can copy it to the clipboard, but you can always generate a new token. So I can close this and I can go back and create a custom token. And I want to show you something that's custom token. The custom token, if you look, I can select a role. So I can decide if I'm using this in application, should this application be read-only? Maybe my application lets the user search for things in the database, but the user's not going to actually update anything. So following the important security principle of least privilege, I only want to give my application and thereby the users of the application permission to do the things that they need to perform their tasks. And in some cases, I see Slack is trying to add something, but I don't see that on my screen. Oh, never mind. I have too many computers, multiple computers, and multiple screens. But this lets you define the kind of permissions you want for a role. So maybe I want, an administrator role. And it tells you, hey, here's the permissions for administrators. And then it will let you generate a token with those permissions. So be careful. I'd recommend that you always generate custom tokens so you always know beforehand exactly what permissions you're using. I have worked with some folks who have assigned the wrong permissions. Sometimes they didn't assign enough, and then their app didn't work. Other times, maybe worse, they ended up assigning a high level of permissions to an application that didn't really use it, creating a potential, not necessarily likely, but a potential security vulnerability. So we really want to be careful about that. So that's our tokens.
That is well said. So one thing, if you look at our table, we were looking at the temperatures earlier. So most likely your app is just displaying the temperature at a given location. That means you just need a read-only privilege. You don't need to update it. So the update comes from a different source. It comes from the backend system. It doesn't happen through the application. So always give only the least required permission. And I have seen scenarios where they give least permission, their app does not work. They just bump up to go to administrator privilege,
Right.
Which is a wrong way to do it.
Absolutely right.
So just want to remind, you have to understand what you're doing with your database now is open on cloud, and you're creating a token which can have highest privileges. So just be careful.
Yeah. Good security practice everywhere. So what we've done now is we've created our database. We talked about the REST API. Now you've had a chance to at least look at it using Swagger. So that's part 2 of our online or of our hands-on material. So next, we're going to look at Netlify in the back end, and we'll do that primarily through the IDE. So we're going to continue here and watch closely. There's a little bit of magic happening in the background here. So I'm going to switch back, and Netlify setup. It says right click and select open as a new tab, and that will deploy to Netlify. So I'm going to do that. And what's going to come up, it says welcome to Netlify, get your site in 1 minute. You may say, well, wait a minute, Dave, what are we deploying to Netlify? And the answer is, if you go back here in the workshop, in this GitHub, it's a real GitHub repo, there is a directory called functions. And if I were to expand that function, I'm not going to do it here because I don't want to mess up my screen. You'll see the functions later. But there are a number of JavaScript functions that make up a basic CRUD API. There's a function to connect, and I believe there's an add, delete, and update function provided in JavaScript. That's what's actually being deployed to Netlify. So I'm going to go back to Lab 3 IDE setup, deploy to Netlify. Here's the page. And Netlify needs to connect to GitHub. So I'm going to connect to GitHub, and I'm just going to continue. I'm not going to grant any further access. And let me explain what's going on here. I've been working out of the DataStax developer, or DataStax devs GitHub. You're now being asked, since you used your own GitHub credentials to log in, Netlify is asking permission to essentially clone our GitHub repo, Workshop Astra TikTok, into your GitHub. So I've been working out of DataStax devs, and now I'm going to work in my personal GitHub, which is Dr. Chung 5. So that's what's happening. And it'll take just a minute. It's connecting to my personal GitHub. And here you can see that I'm in Dr. Chung 5. That's really important. You want to be outside of the DataStax dev GitHub. And it's going to go through a series of steps in deploying this application and using Netlify to take this application and by the way, the page you're looking at is Netlify. Netlify is talking to Dr. Chung 5, cloning the repo in there, and now deploying the content to a CDN. And if you're not familiar with the phrase CDN, CDN stands for Content Distribution Network, and it deploys static content. Talked about that before. We said we're going to generate static pages. That's what Netlify is doing right now. So we're going through the deployment steps, and we'll see it's going to take a minute to go through. So we authenticated, and the site deploys in process. We're actually looking at the build process in the Netlify screen. We said we want to be sure that we're in. Something failed. That's not good. Let's see. That's what. Build command failed. Okay, so I'll give this another try. Let me close this. I should have done that. Okay, so I'm going to go and run this again. I'm going to have to make a little bit of a change, create Astra credentials. I'm looking for step 3, deploy to Netlify. What I'm going to have to change here is the name. I'm going to connect to GitHub, give permissions. I'm going to have to change the name because in Netlify, it created a new project called Workshop Astra TikTok, and in my GitHub, since I gave it permissions, it created a new repo called Workshop Astra TikTok. So that's why I had to change the name here, or to just delete the project in Netlify and delete the project in my repo. So this is how you know that you are actually watching a live example, because occasionally things don't work the way they're supposed to. But here's the process. Initializing. If I go out to my own GitHub, DO Chung 5. And look at the repositories tab. It should show the newest on top. And there's the one that failed. Here's the one that the new one that Sarma, cross your fingers. I'm really hoping works this time. I've run through this lab a couple times and it has worked each time. So we'll see what's happening here. So deploy details, it's deploying. Building unloop routines are not working. Cleanup processing skipped. So let's see. If we can figure out what's going on in this.
While you're looking at that, so live sessions are always fun,
Yes, indeed.
because we get to see all kinds of scenarios. Like, if everything worked, people will think, oh, this is a curated video, So live is always fun. We get to learn more stuff.
So let me see if we can. Let's look at the building. Let's see what failed. Envelope routine is not supported. Let's see.
Do you think something related to credentials?
No, it's a node issue. But I'm not 100%. I was able to get past this and get it to work yesterday and earlier today, but I think I know. So where were we? We were here and we said deploy to Netlify. I'm going to open and get pod. The issue is there's a breaking change in a node version. And for some reason, I got it to work. I run through this twice and it worked fine both times for me. But one of my colleagues said, hey, you may run into this problem. Told me that about an hour before it started. And I said, I'm not worried about it. I haven't run into this problem. And now I have. So let's go. I'm in GitPod, and GitPod is that online development environment. And I'm going to downgrade my node installation.
I have seen similar thing with when Python new version came out.
Right.
They deprecated some stuff. And even with our CQLSH with the specific version of Java build, it had same issues.
But it shouldn't have broken back where it did. It should have broken when I go to Netlify, use the dev command. So we'll see if the downgrade here fixes it. If not, we'll walk through and show how it's supposed to work, and I'll work on the solution.
Yeah, I'm not too worried about this specific step here because I've seen the same thing with Java, right? I was mentioning. So what happened was, for a while they've been telling, like, for 30 releases or so, they've been telling, okay, we are going to deprecate this. So, we never paid attention. We kept using it. I say, okay, there is a new build patch. We apply the patch and our SQL asset stops. So you cannot connect to node tool anymore, right? Or node tool status will give error. So I have seen that before.
Yeah. Okay. So let's try the deploy to Netlify now, having in the Gitpod environment downgraded. Let's see what's running. Okay, no problem with what's running. Can't I open a new tab? Okay, open a new tab automatically. Connect to GitHub. Give permissions. I'm going to be an optimist and say Workshop Astra Tik Tok works, because this one is just going to work. Okay, it's deploying, but we got this far before. It's the build step that became problematic. All right, I'm an optimist. And I know I'm in the right place, DRChunk 5. And here's the URI for my app. Not in the build step yet. Still in progress. Okay. No, it failed. All right, I'm not going to try to debug that live, but I will show you what we're trying to do. Like I said, the issue is, when one of my colleagues pointed out, the issue has to do with the version of Node. And the challenge is we're working in different environments. I'm running on Mac on my desktop. I'm running on Gitpod in the cloud. We're also running the Netlify environment, and you need to update the right things in the right place. So there's something going on there that's causing that not to work. But as we go through, what you're supposed to do then is, let me back up. We save the token, and with the token, you can run an Astra CLI command. And the Astra CLI is going to, let's see, I still have a Gitpod open here. So I can actually do that. I'm going to paste. I'm going to do that off screen so as not to share the live token with the world. Let me run that command. What this is doing is, in our command line, it's setting us up so we can run Astra commands without going through the Astra UI. And as Sarma said, in Astra, we need the token to do that authentication. So I have that, I ran that, and it ran connectly. You see it says configuration has been saved. Setup is complete, and I didn't save the token, so it's not visible. So I'm going to go, and now I can use Astra commands. So I can list users. And I'm the only user, dchung at dchung.com. I can list databases. And I have two databases, the workshop database and the one I called my throwaway database, DaveDB. And I can get information about the database. Again, how else could you do this? Well, I could have used the REST API or the document API and gotten information. I could have used CQLSH, the Cassandra query language shell, in order to get these commands, but this is using yet another way of accessing Astra, which is the Astra command line interface. Then what it was asking me to do is create an environment file. And this command creates a file that has the environment variables necessary to access the database. How does it do it? Well, I set it up and gave it my token. So it's going to do that, and here's a sample that it created. Then I can install the Netlify CLI. And this is where I thought I had to downgrade before I do Netlify dev. But I didn't get that far because the build failed. Once you do that and do Netlify dev, it's going to run, and notice its status, it's setting up the edge functions environment. Let me show you what that means. In the workshop, you have functions. And there are 5 functions: add data, edit, and posts. You also have the Astra client JS. This is going to use the environment variables to make a connection to Astra. Then the add function, notice it requires the client, so it has to connect using the client, and it's going to get a collection and then add data to it, or add a collection. This is going to add data to a collection. This is going to allow you to edit, and this is going to allow you to do a post. Remember I said Netlify is a lot like AWS Lambda. It gives you a place to run these very simple JavaScript functions that allow you to expose a very powerful API. And when you run the app, and I even had this running this morning before we started, you should be able to see this simple TikTok app. Shows you a couple of users. There's a couple of videos that are linked. And if you click the upload button, it lets you upload a new video by URL and give it a name. And in Swagger, you can use the document API. As we said, here we're looking at the collections, the namespace, and we see the 2. This collection was actually created, the story collection was created by us manually, but this collection, the TikTok posts, was created by Netlify when you started it. And the author says, well, you can look at the documents that were created, and they should match what you see in the functions. And then finally, to put together the Astra client, as we said, here's the client functionality. It uses the database ID, which is a UID, the region, which is US West 1 or whatever database region you chose, and then the token. And those 3 things are what's necessary, as Sarma said, to connect and create a client. And then this is really looking at those functions and what they do. This is part of the Netlify configuration, and the run build failed for us. We failed in that process. And you can go to Netlify and view your site. Netlify has some free usage as well, so we're in the free tier. Notice we didn't have to sign up. We just used our GitHub connections to give Netlify a connection, permissions to access GitHub. And here's the two React components, the home component that views videos, and the upload component is a simple React form that lets you upload them. So that's what this looks like. You can set up authentication, Netlify, a number of other pieces you can do, and you can finally deploy and make this broadly available. But again, because we're having trouble with the Netlify piece, we're not going to be able to do that here. There are the functions we talked about that are exposed, and those are the pieces. What I will do is I'll spend some time over the next day or so adding the workaround into the GitHub repo. So if you come back to the GitHub repository, you should be able to work through and get this working. We are available on Discord outside of this time, so we can go through. Yeah. Oh, I see. That's Sarma's message saying looks like it's causing incompatible issues.
Yeah.
Yeah.
David, just out of curiosity, right? I know you have your environment running there. Can you check what is the node version just to see if we are hitting that exact version problem? I think you have it open in one of the tabs, right?
I may have just closed it. Let's see. Okay, here.
Yeah, I mean, it's not too important, but just check the node version.
Oops, let me type it here. I just forget it was dash version. Well, I've got to spell it with node with an N, as in node.
That's all right.
No dash. Two dashes. Yeah, I did downgrade.
Okay, you did downgrade, so
yeah, so
that's strange.
Yeah, because right, you're right that it's and that's what my colleague Stefano also said. I'm not sure how I got it working without downgrading, but downgrading at least at this point didn't seem to take care of it. So I will look at the GitHub repo and make sure the repo gets updated with the corrected instructions. And if it includes something odd like that, I'll make sure to highlight it so people see that, hey, you do have to do this hack, if you will, to get it to work. But this is what we talked about: deploying to Netlify, using the Gitpod environment, coding against the DB, showing the Netlify functions in JavaScript, how they use the environment variables we created, containing the database ID, which is a UID, containing the token and the region in which the database is deployed. And that's a look, a somewhat choppy look, if you will, at our Netlify application. As I said, I will work on updating that, and feel free to use the Discord if you have issues after the update. And I'll make sure that the repo clearly says that Netlify node issue has been fixed. These are the 2 pages of the application. And here's what it looks like running. Uploading a video. You can follow. You can suggest accounts. You can add videos. Pretty simple, but cool functional features. This is some of the JavaScript React stuff. So you said we're not going to focus on this because React is a whole different environment. There's a lot going on in this little slide. But as far as resources, you have our GitHub resource, workshop, social media, TikTok, DataStax devs. You have your Gitpod repository. You'll need Netlify, and you'll need to create an Astra DB free Netlify account as well.
So just to repeat again, right, to sign up for AstraDB, we don't need to give the credit card.
Right.
So that really shows how much DataStax is committed to the community to keep it available for anybody. So no credit card required to sign up. So that means you never run, a huge bill without noticing.
Or automatically renewing, like a lot
Yep.
of things do. And why have I been paying 30 a month for something I don't use? So we are available on Discord, dtsx.io/Discord. We are available on the DataStax Dev YouTube channel that you're watching. If you subscribe, you'll be notified when there are new videos coming up. We're kind of in the process of changing the format of our videos. And what you're likely to see are more short videos from subject matter experts all across the country, not just those of us in developer relations. You'll see things on Cassandra 5 as we get closer. In fact, there's some in Cassandra 5 from our Cassandra Forward event. Sarma's wearing a Cassandra Forward t-shirt. Mine's dirty, or I'd put it on too. Like ACID transactions, a big deal coming at this great t-shirt, Sarma, in Cassandra 5. That came from our Cassandra Forward one-day seminar, but subscribe and keep up to date on the latest stuff. Also, we have DataStax Academy, and that's available at datastax.academy. There are free self-paced hands-on training. We have 3 fundamental courses: DS201 Foundations, which is useful for everybody using Cassandra, DS220, which focuses on data modeling, and DS210, which focuses on operations and performance tuning. DS201 is really the prerequisite for the 201 for the others. And if you complete DS201 and 220, that's one what we call learning path, or DS21 and DS210, another learning path, you qualify to get a free voucher good for 2 attempts at our certification exams. So if you finish 2 classes, you get 1 voucher. You can use it twice and get Cassandra Administrator and Cassandra Developer certified, or one or the other, or both. So that's at datastax.academy. And then our friend Sharma is going to share something really cool with you. Go ahead, Sharma.
So last year, end of last year, I had some time where I was spending some time looking at AstroDB features and all that stuff. I said, okay, this is very useful if we can create a curated course, right? So I created a Udemy course, which is called DataStax AstroDB. And it goes through a lot of topics. It starts with the database. It talks about streaming. Recently, Astra has a service called, what is that, like blockchain?
Yep.
So there are a lot of services being integrated into AstraDB, all accessible through one portal, like AstraDB portal, right? So there is a full-length 4-hour course, and the URL on this slide, also I put it on the YouTube chat, that will allow up to 1,000 people to register to the Udemy course for free. All I ask is give me the 5-star rating on Udemy. So go ahead and register for this course. The coupon is valid for next 4 days. So take full advantage, give it to your friends, family, whoever needs to learn. As a community member, I'm really proud to be part of the community. And this is what we can do together. Like, we can learn together, we can train together, and we can create together. So yeah, thank you very much.
Yeah. And Sarma, thank you so much for joining us today. I'm happy to have you as a friend and in the community as well. Also, take a look at Sarma's course. And Sarma asked you to give a 5-star rating. He didn't really need to. His course rocks. So I know you'll want to give it a 5-star rating. Anyway, good stuff on learning more about AstroDB. All right, so we're we are actually on time because we didn't go through the hands-on in detail.
Actually, we did very well. Like,
Yeah,
even though it failed build, I have seen that happening before, right? It's just
right.
not in our hands because there are version changes. Something was
Yeah,
released last night, which was not under our
right. This
control.
is
So
proof, and we're still live. This is proof that we're live. That this isn't recorded. We are doing this hands-on. I want to thank you for joining us. Again, hope you'll take a look at Sarma's excellent courses and stop by DataStax Academy. I'd love to see you celebrating on LinkedIn your certification in Cassandra. So until next time, thank you and have a good afternoon, morning, or evening, depending on where you are in the world. Thank you, everybody.